All right. Well, welcome back, everyone, to Technical Track B. We have three more exciting technical talks in this track. Next up, we have Aria Fredman, Senior Data Scientist at Gideon Health, presenting using all-ish the data, validating your data usage decisions. Aria, just a reminder to set your timer and enjoy.
Okay, am I unmuted now, finally? Did I click the right thing? Yeah, Gwen's smiling, so I'm assuming. Okay, awesome. Yeah, so hi, my name is Aria. And now I'm actually more of like a product researcher, but in my last job, I was an R&D data scientist, and we used to get a ton of data from which we were trying to infer causation. And as I'll talk about shortly, it's not necessarily a great idea to infer causation from correlational data. And some of this comes back, I think, to the question at the end of the last talk, which was an amazing segue about self-selection bias. So the space that I wanted to concentrate my talk on is the space between kind of EDA and validating that your tests are reliable. So we all know that, when we get data, we have to check if the data are what we expect them to be, right? So we want to know that if we're expecting words, they're words, if they're numbers, they're numbers, what the range is, and so on and so forth. And then also, of course, if we are the type of data scientists that built a model, then we want to verify that, validate that as well, right? So you might have test sets, holdout sets, and so forth. But there's also this space kind of in between, which I think is, addressed certainly by some, but oftentimes is ignored. And in terms of this space, I think it's more, where possibly like the bulk of the critical thinking comes into play. So here are the types of questions, such as, well, these are people that self-selected, can I really infer causation from that come into play, as well as, how should I engineer my features? What exactly can or can I not do with these data? And what I've actually found a lot of times, certainly from people who aren't data scientists, who are hiring data scientists, but even from data scientists sometimes, is that the term data science is often synonymous with machine learning engineer. And, I think a lot of the times it comes down to a machine learning algorithm, but not always. And even before you get into building the algorithm or tuning it, there are a lot of things that you have to consider about your data. And I don't know if this is, more of an experience type thing, where after some time you realize, oh, well, I can write code, but let me think about this a little more critically, or if it's just, different types of strokes for different types of folks, I think is the idiom in English, but yeah. So one situation in which, it's really important to consider what's going on is that of a quasi-experiment. So unlike a real experiment, which we'll talk about shortly, and others have talked about earlier today, in a quasi-experiment, we have this self-selection issue. So let's say I have this question, I have this app, and one of the features on it is social usage features, and I want to know, does using the social features lower people's stress? So if I've already deployed the app and I have a bunch of telemetry data, then I might just want to say to myself, okay, well, I'll look at the stress levels of the people who are high in stress and the stress levels who are high in usage and the stress levels of people who are low in usage, and then see if I can compare across groups. And, as we'll see in a minute, maybe that's not such a great idea. What would happen in an experiment would be I'd have a large group of people and I'd randomly assign people to say, here, you must use these features, 3 hours a day, or you must use these features exactly 10 minutes a day, and then compare the stress rates across those groups, as opposed to just letting people do what they want and then kind of see where the pieces land. And the reason that it's not a great idea to necessarily draw causal conclusions from correlational data is that while it is possible that there's a causal correlation there, right? It's possible that the social feature usage is what's causing the stress to decrease, there are also a number of other hypotheses that are equally plausible in this situation. So there might be a third variable that can explain the first two variables, right? Maybe somebody's social group in real life predicts how much they're going to use the social features in the app, but also is what's causing them to lower stress. So if I take the time and money to create an app where people are going to want to use the social features more, I just wasted my time and money, because that's not what's going to lead them to lower stress if I can't change their real life as well, or their life outside, their non-virtual life, right? And it's also possible that we have this causal relationship, but it's reversed. So maybe people who are lower in stress, you know, have this predisposition to engage more in anything in the app, or to engage more with the social features. But the point is that with just correlational data, I won't be able to know which of these is correct. And, you know, as I think I was hinting to this, right, this is a problem that if you don't answer correctly, you're going to give someone the wrong actionable insight. Because if my question is, should I take the time and money to rebuild my app to increase social features usage, right? If my point at the end of the day is to lower people's stress, and all I have is correlational data, I may have just spent all this time and money to try to figure out how to increase the usage and how to redesign the software and hardware, and not actually get anywhere with those results. And so, you know, kind of just to conclude, I think it's important to highlight that what we're looking at is, what we want to do is compare Matt. Let's say Matt's a person who uses the app, the social features, at the 75th percentile and is at the 25th percentile of stress. And I have a person named Amy who's at the 25th percentile for usage, but the 75th percentile stress. I don't want to compare Matt to Amy and say, oh yeah, you know, social features, clearly they're what's causing the stress levels, because, you know, maybe Matt gets massages 3 times a week and Amy makes $10,000 a year and never gets massages. You know, there are these other things if we let people self-select. So what I really want to do is actually not even an experiment. What I want to do is get a time machine, right? And see what Matt's doing under certain conditions, and then go back in time and make Matt, you know, participate in the other group, and then see how Matt reacts. And that's really the only real way to compare apples to apples, as opposed to, you know, apples to oranges. But maybe you do. I don't have a time machine. And so my second best choice is to do an experiment or a randomized control test. And the way that this kind of takes care of the issues that we've been talking about, and my timer closed. Okay, we'll just wing it. And the way that this kind of controls the issues that we've been talking about is by taking a large group of people and then randomly assigning them into the control or the test group, right? Telling them use the app for a low number of hours, use the app for high number of hours, is that the chances are that if there is a confounding variable, I'm spreading it equally across these two groups. So if I have a large group of people and, you know, some of them are also getting massages, if I force them into one of the two groups, they'll be equally spread. And that way, you know, since I have the people with the confounding variables in both groups, it's reasonable to assume that the variable that's causing the difference in the mean stress level for the group, if there is one, is the only variable that I've controlled and that I've made sure is the different one between groups. But, you know, like, as I've pointed out, we don't always have that luxury. I certainly didn't have that luxury. And so one way to get around that is to use something like course and exact matching, which I don't have time to go over right now. But basically what you do is you're going to construct comparable groups from the people whose data you do have. And so, you know, if there are people in the high usage group who get a lot of massages, I try and kind of find the people in the low usage group that also get a lot of massages. And depending on how many I have in each group, I kind of weigh their stress level accordingly when I calculate the means of the groups. And that way I kind of take into account the confounding variables across groups and I put them into the equation. And this, just like with a randomized experiment, in theory is going to guarantee that the groups only differ on the variable of interest. Now, as you might have suspected, this also could lead you to be quite data poor, right? Because for one thing, in order for me to match people, I actually have to have people across the groups that I can match on. So if you don't have someone, then you can't use their data. The other thing is that depending on what you're studying, let's say someone subscribing to your newsletter or buying from your website, that's the kind of thing that just doesn't happen frequently, especially if you're looking over a shorter period of time. And so you may not have a lot of data because of that. Another issue might be that you have to remove some data. So let's say I'm going to define using the app, over the course of 2 weeks. Then in an ideal scenario, I would take people who the first day used at the 75th percentile, and then for the next 13 days also used every single day, at least at the 75th percentile, and then the same thing for the 25th percentile. But chances are people either at the first day didn't even use that much or that little, or they started there, but then kind of, fell up and down depending on if they had a busy day or what have you not. And so if we only want to use like the quote unquote purest data, the least noisy data, then we're going to have to throw out a lot of data because of that. And, what I've learned is that sometimes you throw out too much data and you still have to give an actionable insight. You don't really have that luxury of being like, well, I don't want to put these data in. They're kind of noisy. How noisy are they? Well, so that's when I had to start realizing, okay, I'm going to have to quantify the noise and figure out what I can put back in. And so this is, I guess, where like the crux of the talk starts. So what I want to do is try and figure out, how can I get some of that noisy data back into my model? So I thought about quantifying the data in 2 different ways. But first, let's define, what the purest data would look like, which I think we already talked about, which is the people who started in their assigned group, quote unquote assigned, right? 75th percentile, 25th percentile, and then stuck to that level or higher or lower every day. And then the dirtiest data would be, right, the people who were either 75th or 25th percentile the first day, and then the rest of the day fluctuated. So somebody was at the 75th percentile or higher the first day, and then starting day 2 through day 14, they used at the 30th percentile, they're still going to be labeled high users and be left in that group. But we can also think about what are the degrees of noise here, right? And so in terms of degrees of time, what I think about is how far away from the starting point are we? So I might say, well, obviously if they didn't use it the assigned amount the second day, then I'm not gonna put them into my model. So I'll say, okay, up to a week. A week sounds reasonable to me. So if that person used at the 75th percentile the first day, and then 75th or higher second, third, up until the 7th, and they only kind of dropped off the wagon a little bit after that, let's say they didn't go below 60th percentile, I'll keep them in. And another way to conceptualize the degrees of noise is to think about the degrees of frequency. So again, the pure and the dirty are going to be the same thing. So the pure is the people who are always in their same group 100% of the time. The dirty is where they've only that first day, the rest of the time we don't really care or think about. And then the degrees of noise is going to be the relative amount of time. So let's say I want to say at least 60% of the time or 75% of the time, they had to be in their quote unquote assigned group. And if they did that, then I'll kind of like give them a pass and still keep them in my model because I need more data. And also I think it pays to mention that sometimes the noisy data is actually like what real people are, right? Like people will use it a lot, but not all the time at the same level. So we got to take that into account. So here, and of course we can mix those 2 together, right? So I could say that it has to be that the first week they were in the assigned group, and then the second week, no more than 50% of the time were they below 75th percentile, something like that. And that way we can kind of like start putting together something that makes sense, that somebody can still fit into a category, even if they didn't strictly fit all of the guidelines. And so of course we have the question of, how noisy are we willing to accept our data? And yes, I really had to use that meme, I apologize. Okay. So one thing that you could do is just, think about logically. And if there are previous findings, in the field, you could look at psychology research on stress and socialization and so forth, and think what makes sense, right? Like putting everyone in as long as they met the first day does not make sense to me. And I'm probably comfortable if they were like the first 3 days and then didn't go below 60, but at least 50% more of the time, right? Like there are different things that we can be comfortable with still logically. So we kind of have to take it usually one step further. So sometimes we can like quote unquote rerun the experiment. So if we have, data across a year and we're only looking at 2 weeks, then we can probably randomly choose different units of 2 weeks and kind of compare those and see what's going on. And then if this is a process that has been run before by you or someone else, or some sort of iteration of it, like someone's already done the very pure version of it, then you can kind of compare and see what's going on. Because if it's, you know, like, we're not going to find the ground truth, right? And like, all models are wrong, but some are more useful than others. And so what we're really looking for is to kind of see if there's a pattern that echoes. Depending on your field, at least in the one that I was in, like, more data always produced the nicer graphs that like sales wanted or whatever. And I want to make sure, A, that I'm doing good data science, and also that I'm not selling something that isn't real, because I think at the end of the day, it'll come back to us. But beyond that, so the way that I kind of looked at that was to try and find a pattern, because if something looked really good, but then in another time period, it kind of like completely disappeared, or the, confidence intervals are through the roof, then kind of like let it go, even if it's going to give you the nicer graph. And okay, 15 minutes. Thank you.
That's perfect, Aria. Thank you. And we'll just go ahead and transition to Q&A. So just a reminder to participants to drop your questions into the Q&A section and upvote them for the ones that you'd like to see answered. And we'll just wait a minute or two, see if that populates.
Okay, so first question is, what was your finding on stress? So this is actually a hypothetical situation, because what I actually worked on was the efficacy of television advertisements. So to see if advertising on TV actually led to higher conversion levels. So I just wanted to give an example from a domain that wasn't exactly what I was working on, especially since I'm no longer working at that company. My hypothesis would be that there would be an effect, but without controlling for certain variables. I mean, I think it would be in real life an effect, but a small one. And this is actually based on my background is a PhD in psychology. So based on what I know in psychology, like the number of friends you have is important, but so is the quality of relationship. So my guess would be that there is an effect, but a small one, but that wasn't the project. In terms of how big is big enough data, I think that it really depends, right? Because it's going to depend on how spread out the mean is between your two groups, right? How big the variance is between the groups, how likely you were to get people who, let's say, converted, if that's what you were looking at. And so all of these things are going to determine the size of the data that you need in order to find an effect. And of course, if you're also doing matching, then it also depends on, did people randomly select into one group more than the other who had confounding variables, because then you'll have trouble matching across groups and you'll have to drop even more. Okay, so assuming I understand the question, how do you measure how good the constructed comparable groups actually are? So if it depends on what method you're using. If you're using coarsened exact matching, then there's a metric that's called LCS, which stands for local common support. And what that's going to do, it's going to describe the percentage of groups that have at least one treated and one untreated person. So basically, it's kind of giving you a measure of how much data you threw out. Of course, it can't tell you, did you choose the confounding variables or not, right? Like that's a lot of critical thinking that's going to have to go in there. And usually a low LCS means that it's a bad variable choice. And the more variables you have, the harder it's going to get a high LCS. But the truth is that even if you're your LCS is low and you threw out, which means that you threw out a lot of people, you should like critically think about that. Because let's say you had like 1 million people in your control group and only 1,000 people in your treatment group. If the LCS is low because you threw out 50% of your control group, that might be an issue, but it might not be an issue. It depends on your specific use case. So it always comes back to it depends, unfortunately. Thank you for those really good questions.
Yeah, and thank you, Aria, for the amazing talk. I really appreciate it. That was great. All right, so next up